Hey everyone, we are going to start on page 3 of the sample exam 2B in your course packet. So this is problem 13, and I'm given data for 12 venture capital investments, and I'm asked to calculate a confidence interval. And so I'm either going to calculate a confidence interval for proportion or a confidence interval for a mean. But I see the word average. I'm also given S. Those are two big clues that I want a confidence interval for a mean. And so I'm either going to use this formula right here or this calculator function right here. Okay, so let's go back to the exam. The first thing I need to do if I'm going to use the formula is calculate the sample mean. Usually it's given to us in a problem, but in this particular example, it's not. And so I want to calculate x bar. And what I do is I just sum these numbers up and divide by 12. And so I get 6.04. At this point, you guys should know how to do that. And then, so my confidence interval, I want to calculate a 90% confidence interval. And I need to go to my t-distribution table. My n is 12. That means that I go to row 11 on my table. You just take n minus 1. So here's my t-distribution table. In the bottom here, there it is. The bottom of the t-distribution table, we want a 90% confidence interval. I go to row 11 because that was n minus 1. And so here's row 11. And so I would use 1.796 in my formula. So that replaces z for our confidence interval. For our mean, we want to always use t. So what I do is I take x bar, 6.04 plus or minus 1.796 times s, I'm just using my formula here, divided by the square root of 12. Okay, so there's my formula. And I get a lower bound of 5.00. And an upper bound of 7.08. All right, some of you don't like to use the tables, so you prefer the calculator function. So we can do that. Now I have two options. I've already calculated the sample mean, 6.04, so I'm just going to use that option. The other option is to enter your data. But let's go to stat and then test. And then the formula sheet says number 8, t interval. So I go down to number 8. Let me show that you might be able to see that a little better. So t interval. Now if I've entered my data into L1, I would go to L1. I would go to highlight data, but since I've entered my data, I already computed my sample mean. I'm just going to use summary statistics. And so now I go down to x bar. That was 6.04. S is given as 2. Our n is 12. And our confidence level is 90%. And then I just go to calculate and I hit enter. Okay, and so it gives me a confidence interval, the same thing that we calculated there. And I want to interpret it. So this is a confidence interval for the mean. There's no correct interpretation of this confidence interval unless I use the word average or mean in my interpretation. And also I want to be careful to put units on there. The units are given as millions of dollars, so it's important to keep those units there. Okay, so we are 90% confident that on average, all venture capital investments are between, let's see, $5.0 million and $7.08 million. Okay, so I mentioned the 90%. I mentioned the word average. That's important because that's what this confidence interval is for. And I extended it to the larger population. It's not just for, this confidence interval isn't for the 12 observations that we had, because I know the mean of those 12 observations. I want to know the mean of all venture capital investments. That shouldn't be an I there. All right, let's go on to the last page. We want to conduct a hypothesis test. And we have a manufacturer considers this process to be out of control when defects exceed 3%. Test the claim that the production process is out of control. Use a significance level of 0.05. So the first thing I want to do is state the null alternative. And I need to figure out if the parameter is P or mu. Remember, P is for proportion. In this case, we would want to figure out the proportion of defects. And so the parameter is going to be P. And we're comparing the data to the value of 0.03 because that indicates that the process is out of control. And so the alternative would be that P is greater than 0.03. Because the claim is that the production process is out of control. That would mean that the proportion is greater than 0.03. Now I could go to my formula sheet, and what I want to do is do a hypothesis test for proportion. So here's proportion. If I'm using the formula, I'm going to use this formula right here, or I can use the one prop z test. Either way, we get a test statistic and a p-value. So I'll go ahead and use the formula. The first thing we need to do is figure out our p-hat. So p-hat is going to be the sample proportion of defects. So I take 28 over 500, and that's equal to 0.056. And so my formula is going to be p-hat 0.056 minus p. That's always what's here. So that's going to be 0.03. And then I divide by the square root of p times q. P again is 0.03. It's important that you get your p-hat and your p's straight. And q is always 1 minus that, so 0.97. That's also under the square root. And divide by our sample size of 500. So just real quick, look at that formula again. This is the formula I just used. I took p-hat minus p, divided by the square root of p times q divided by n. Whatever you have for p is what goes in the denominator. All right, so this is equal to 3.41. And I want to report the p-value. So I go to my normal table. And here's 3.4. 3.41 is right here. So my area to the left is 0.9997. However, you want to subtract from 1 because this is greater than. If this is greater than, you want the area to the right. And so I take 1 minus 0.9997 to get a p-value of 0.0003. So 0.0003 is my p-value. Let's jump to the calculator and do it on the calculator. My formula sheet says I go to number 5, so I'll do that. So stat test number 5. And then I have to enter the information. P naught is whatever is in your null hypothesis. So think of H naught and P naught. Those are the same numbers, so 0.03. And then 28 is the count for X, and my N was 500. Oops. And then I need to enter the direction of the alternative. So alternative had greater than, so I enter greater than, and then enter for calculate. Okay, so it's important to be able to read the correct information off. What I'm interested in is my test statistic 3.41, just like we got when we did it by hand. And then the next number is the p-value. So this says -4. That means I move the decimal point over 4 spaces. So my p-value is 0.0003, just like I got when I did it by hand. All right, so the final time, we are interested in answering the question of whether or not the production process is out of control. Same thing as exceeding 3%. If you go to the very top of the test, we're going back here again. The number of times we go back here during this test tells you how important it is to know that. But our p-value is less than the alpha level, so we can reject the null. So I want to state that in my conclusion. And since we're rejecting the null, that means we're going to conclude the alternative, that the production process is out of control or that the defects exceed 3%. Either one, they mean the same thing for this problem. So conclude that the defects exceed 3%. Again, you're either answering the question whether the defects exceed 3% with yes or no. If you reject the null, then you would conclude that yes, you found evidence for that. If we didn't, if our p-value was large, then our conclusion would be that we did not. Okay, let's do the last question. And this goes back to something I said earlier. Confidence intervals and hypothesis tests agree with each other as far as their conclusions. So you don't have a different conclusion or a conflicting conclusion for a confidence interval with a hypothesis test. They should be consistent. So it says, suppose that the 90% confidence interval for population mean has been calculated to be between 27.4 and 29.6 based on a SRS. The p-value for the following test would be, okay, so again, we're looking to see if 28 is included in the confidence interval or not included. So we want to decide whether our confidence interval agrees with the null or the alternative. Because 27.4 and up to 29.6 includes 28, then we say it's consistent with the null hypothesis. Hey. Uh-oh. back. There we are. Okay, sorry about that. And so this is consistent with the null hypothesis because 28 is inside those numbers. And if it's consistent with the null hypothesis, our p-value would be large because we would not want to reject it. A large p-value implies that you don't reject. And so in this case, it would be larger than 0.01 because we wouldn't reject the null if p-value is larger than 0.10, sorry, not 0.01. So larger than 0.10. All right, that's it. Good luck on your exam. Make sure you go over the other test as well.